Well, welcome back to GIS Analysis at the University of Alaska Fairbanks. In this session, we're going to reclassify our test raster. As a reminder, our test raster has values ranging from 1 to 100. So basically, each pixel is a value of 1 through 100. We could symbolize our raster. So if we go to Properties, let's classify our raster. And then if we click on the Classify button, interval size of 10. And then let's assign a color ramp. So green to red. So 1 through 10 will be this color green, 10 through 20 will be that color green, all the way up to 90 to 100 will be this color red. So it's easy to classify a raster in terms of symbology. But what we might want to know is, well, how many pixels have values from 90 to 100? How many pixels have values from 50 to 60? So to do that, we can use the Reclassify tool. So the Reclassify tool will output a new raster, and it will group pixels based on ranges of values. So examples of reclassifying, you may want to reclassify an elevation raster into elevation zones of 100-meter elevation zones. Or you might want to reclassify a land cover raster into a raster where 1 is a vegetated pixel, 0 is a non-vegetated pixel. Or you might want to reclassify an air pollution raster where 0 is healthy pixels and 1 are unhealthy pixels. So we can do this all using the Reclassify tool. So our input raster will be our test raster, and then if we click on the Classify button, there's many methods we could classify by. So let's choose Define Interval, and then our interval will be 10. So then values that have from 1 to 10 will become in our output values of 1, and then values from 90 to 100 in our output will become values of 10. So we'll create a new output raster, and let's name this raster Raster Interval 10, and then just OK. So that creates a brand new raster. So then we know that there's 10 pixels in the first zone, there's 10 pixels in the last zone. Now 6 months from now, we may forget, well, what does the value 1 represent? What does the value 5 represent? What does the value 10 represent? So it's always a good idea to, after you reclassify, run the zonal statistics as table to get the minimum value and the maximum value from the original raster in this table. So our zones will be the raster that was output by the Reclassify tool. And then what we want to know is, for each value in this output from the Reclassify tool, what is the original minimum and maximum pixel value? So then the value of 1 ranges from 1 to 10. The value of 2 ranges from 11 to 20. The value of 10 ranges from 91 to 100. So then our final step is we'll use the Join Field tool to transfer this information to our raster attribute table. So we're going to transfer the minimum and the maximum to this table using the key field value and value. So we're going to transfer from our table to our raster. And we're going to base that on the key field value and value. And then what we want to transfer is the minimum and the maximum. And then just OK. So now 6 months from now, we'll be able to determine that, okay, a value 1 in this raster is representing from our original raster all the pixels that range from 1 to 10. And a value 10 in this raster is representing all the pixels that range from 91 to 100 in the original raster. So let's say we have our original test raster and we want to create a new raster representing low, medium, and high, where low is values, let's say, 1 standard deviation less than the mean, and high are values 1 standard deviation above the mean. So we can use the reclassify tool and then classify by standard deviation. So this will be the value that's within 1 standard deviation of the mean. So let's give it a code of 1 if it's not that value, and a code of 3 if it's above that value. So 2 will represent it's within 1 standard deviation of the mean. These classes represent it's less than 1 standard deviation from the mean, and these classes will represent it's 1 standard deviation above the mean. So then let's output that as a raster named low, medium, and high. So then we can add a field to our raster attribute table to describe what the values 1, 2, and 3 represent. So we'll add a text field, and let's give it a length of 16, and let's name that class. So this represents all the pixels that were in class low, so enclosed in double quotes we can give it a class low. And then repeat the process for the medium row and for the high row. And then once again, 6 months from now, we may not know, okay, what does low really represent in terms of the original pixel values? So once again, we'll run zonal statistics as table and then join field to get the original minimum and maximum values in this raster attribute table. So once again, our zones are from this raster, and we're asking about the pixel values in our original raster and return the minimum and maximum pixel values for each of these 3 zones. So that creates our table, and then we simply use the join field based on value to transfer the minimum and the maximum back to our raster attribute table. So we're going to join field based on value and value, and then we're going to transfer the minimum and the maximum to this raster attribute table. So then 6 months from now, we'll know that low represents values between 1 and 35 in our original raster. Medium represents values between 36 and 65. High represents all those values 66 and above. So then we could add that information in our table of contents. So here we could, instead of 1, we could say low, and then we could actually include the values. So it's up to you as a user. For example, you could say low is 1 to 35, or we can use, for example, high is greater than 65. So then we can see in our table of contents exactly what we mean by low, medium, and high.